In this video, we are going to discuss lithostratigraphic correlation. As a warning, this video may be more educational than it is entertaining. What you can see in front of you is a rendition of 4 stratigraphic columns that have been completed from various drill cores. What we are going to do is learn how to correlate only using the lithologies present in each one of these stratigraphic sections, hence the name lithostratigraphic correlation. Before continuing on, I want to note that there are other methods of correlation, but this video is only going to focus on lithostratigraphic correlation. So when we look at that in our various stratigraphic columns here, we can see we have different rock types in each one, and the concept or the goal of a lithostratigraphic correlation is trying to understand the relationship between the various outcrops or the various drill stems. Now, when we are looking at this, we're only going to consider our different rock types. And what we're trying to do is simply match up the same rock type in each section. What we will see is that as you go across or laterally throughout your sections, you're going to get different features, you're going to get different orientations of your correlation lines. Now, before continuing on, I want to make note that if you were ever to complete a lithostratigraphic section, or any geologist were ever to complete one of the things that should be known is you cannot do these over vast distances. You need some other controls to make those correlations. As such, lithostratigraphic correlation is really only useful for outcrops that you can see maybe on one side of the road versus the other, or within a shorter distance, and you know they roughly represent the same lithologies in the same depositional environments. Over vast distances or areas where you're not sure or have no controls, lithostratigraphic correlation should not be the only method of correlation. So with that being said, let's start here. First thing to note is that we can see we have different lithologies or different symbols that are on our various columns here. We can notice that this larger space here, these circles, represents a conglomerate. This space in here where it looks like a bunch of little dots, that represents a sandstone. These areas in here where we can see various dashes, those will represent shales, and the little brick patterns that you can see is commonly known as limestone. So with that being said, we are trying to match up some of our rock features here. So what you'll want to do, okay, if you do not have a steady hand, is take a ruler and start. Now, what I recommend is picking one boundary and continuing across your entire sections that you're trying to work. Some people prefer to go column to column. I'm going to show one working all the way across. So with that being said, we'll start here. So with this clear ruler you can hopefully see through. I am marking from the base of this conglomerate to the base of this conglomerate. I draw it. What this line here represents is at the base of this conglomerate, this one here, in my interpretation, this is equivalent. Now, when going through one of the things that we want to look at here, and I'm going to draw an incorrect line and then I'll erase it, but I want to illustrate this. If you were to do something like this, and you were to draw the base of this conglomerate to the top of this conglomerate here, what you're saying is that my sandstone here is pinching out and I have no way to explain this. It's almost like saying this sandstone is the same thing as this conglomerate over here, which is not correct. So again, let me erase that after showing an incorrect method of correlation. But that is one of those ways that you can check yourself when you're going through, is that are all of my lithologies kept separate from other lithologies? If they're the same lithology, great. They can be together, but if they're not, they need to be separate. And we'll look at that as we complete our column. So back on our aspects here, staying on our conglomerate. Base of it there to the base of it over here. And then continuing like so. Base of my conglomerate to the base of my conglomerate. And I have completed that line there. Now, next step is continuing down. I want to look at my next contact aspects. Well, if I continue down, here's the base of my next contact. So now I'm looking for the base of the sandstone. So I have a base of the sandstone, base of my sandstone. I continue across, do a quick check. Yep, everything in here, this makes sense. This saying this sandstone is equal to that sandstone, that's good. Now I come over here and I've got sandstone, and then it looks like shale and then sandstone. I'm going to say that the base of this sandstone base of this sandstone are the same. Again, coming across, looking over here, I can see I have a number of different sandstones and different lenses. I'm going to say this comes across here. Now, throughout this video, you've heard me say I'm going to say this, or I'm going to interpret it this way. One of the things with lithostratigraphic correlation is there can be more than one correct answer. This is one of the reasons you do not want to try to correlate over long distances. We're going to see in a little bit here, this small shale bed here, what we do with it and how we explain that. Okay? But I will come back to that at the end of this video. So, if we continuing on again, back over here, starting with our column here, up I have a conglomerate, to the base of another conglomerate. Come across, that looks good there. Now I'm starting to run into an issue where I do not have a conglomerate on this side. If I come over here, I do not have this shale over on this side. So what does that mean? Well, that means that we've hit the end of it where we're going to get what we call as a pinch out. So as a pinch out is often drawn, okay, like so. This is one interpretation that you could have, having your lenses pinch out like that, okay, showing that pinch out component. Other times you will see it as an intertunging aspect where the lines are drawn. Let me draw that as well, just so you can see the differences. In some scenarios you will see it actually drawn like this, where it shows that you have an interrelationship between those two facies. So different packages or different bodies of rock from their neighboring rock types. So I, on the other hand, would prefer it to pinch out in my interpretation. So if I come back and I work through this, what you can get, and you kind of freehand, is your pinch outs. And what this does, and this interpretation to me simply says, is that, oh, my conglomerate reaches up to maybe this point here, my shale comes to this point here, I've reached the end of my depositional environment, I'm far enough away from the source environment, the source material, that it's not being deposited. So if I'm interested in conglomerates, or if I'm interested in shales, and I'm talking about how do my facies change laterally, well, that's one of those questions that, again, if I'm a researcher, I want to go back and I want to try to get more data in this area to try to understand these correlations, or to try to understand what's going on in these relationships here. Now, working through, same thing as we see over here, we've got this little shale here. Again, I'm someone who's going to suggest that we get another pinch out, which just means that this, again, the source does not reach all the way across the basin. I could have drawn these pinch outs shorter, slightly longer, just as long as I didn't touch the other side, and I would be fine. This is up for interpretation. So if we continue on, I'm going to come back down and take a look at a couple other aspects here. Let's take a look at this shale line here to this one over here. Again, we can see that we had most likely some kind of shale, so some marine environment working its way back and forth next to our beach environments or our sandstone environments here. If we continue down our sections, it's going to get a little bit harder to see, but we have our sandstone base here, sandstone base here, sandstone base to sandstone base, and so on and so forth. Again, that looks pretty good there. And if we start to come down here, we can start to see that we have, again, a small little sandstone lens here, and then the rest is essentially limestone across the way. So again, I'm going to make the assumption or the hypothesis here that that sandstone pinches out, and my limestone bases will correlate like so and like so. And I'll take another quick look in here. Oh, I can see that I got a little bit more shale over on this side here that doesn't come across. So again, I got another small pinch out there. And now, when taking a quick look through this, what we can see is that I don't have any gaps that say this sandstone is equal to a shale or this conglomerate is equal to a limestone, which is the goal of a lithostratigraphic correlation. Again, we're only correlating rock types. We're not including time or any other types of data. It's just the different types of rock. what we can look from this now is we can start to say stuff like, well, here I've got more limestones and shales than I do sandstones and conglomerates. Okay, well, this more likely is marine. If I come over here, I've got more conglomerates and sandstones than I do limestones and shales, which means this more likely is closer to being inland, where I'm going to have more material coming off the continents. Again, we can look at the way our facies extend laterally. We can discuss which is open ocean to inland. We can look at the changes vertically, so I can look at something like this one. If we pick the middle one here, again, limestones into shales into sandstones, I can see that I have material coursing upwards. This section of the rock column here most likely represents a regression. We'll talk about that in one of my other videos focusing on Walther's law. But now you have an idea of how useful lithostratigraphic correlation can be. And this is how you complete a lithostratigraphic correlation section.